Hello, I'm Matt Kohlberg, Civil Technical Specialist for Cancel. This is the third in a three-part series on corridor targets. In today's episode, we'll discuss elevation targets. In this case, our assembly contains a ditch created from such subassemblies as the generic links. In a general case, this ditch is 750 millimeters deep from the hinge point. And generally that's the ditch design that we're happy with. But in our case, the profile design dictates that in some cases the ditch must be deeper. The blue line is the design centerline profile. The green line is the design ditch profile. The red line is existing ground. In this section, in this station range, the ditch is still 750 millimeters deep, a standard offset from the hinge. Later on in the design, the road must tie into an existing trail. Thus, our road center line goes up and then back down again. Since we want to maintain positive drainage the entire length of the road, we must design a ditch profile in this location. Here it's virtually flat, but that's okay for our design. In this case, we will link this design profile with the associated subassembly. First, we have to determine if the subassembly that is in use is compatible with this design intent. Here's the help file for the subassembly I'm currently using: link, slope, and vertical deflection. If we take a look at the target parameters, we can see that the vertical deflection can be overridden by a profile or a 3D polyline or feature line or survey figure. So yes, this subassembly is compatible with this design intent. How is this done? Here's our corridor. I'll specify targets for this region. Under the slope or elevation target section, here's my subassembly. I've renamed it, I've called it ditch in. I'll apply, in this case, a profile. I'll apply a profile of the Colnbrook Road ditch to this subassembly. Once the corridor rebuilds itself, the ditch behaves as intended. For example, in this section, the ditch is still 750 millimeters below the hinge. In this section, you can see the foreslope getting wider. It maintains 3:1 slope, but as it gets wider, of course, the ditch gets deeper. Here's an example in InfraWorks. Here's what the normal ditch looks like, and in the region where the ditch gets deeper, here's what it looks like. As you can see, the 3:1 slope is extended down to the elevation of the profile. That's elevation targets. My name is Matt Kohlberg. Thanks for watching.